Okay. Here's the schedule for the rest of this semester, as I keep saying that. Today we will do wireless sensor data acquisition. Data acquisition means we set up sensors on Arduino Uno and and see how each sensor can acquire what kind of data. That's what we are going to do today. So I'm going to give you maybe a 1 hour lecture, and then we will do hands-on lab. Next week we will move to the city, Manhattan. There, because of the distance and some difficulties, I cannot carry all the sensors with me through the transportation. I'm going to give you the lecture. That lecture may be also very good for you. That is some physics behind the sensor technologies. So that'll be for the next week, and the week after that, so 2 weeks from today, we'll come back here at Dobbs Ferry also. There we will do a second hands-on lab. Okay. At that time, I may not give you the typical lecture, but I will let you do the work. Some of you may do the group projects. If you do
There's a project for this one? There is a project for this class?
For this class, right? No, this class.
This is mobile technology?
Correct.
Oh, okay.
Mobile technology.
What does that do? Because you posted it and then you took it down. Yeah, I didn't even see it.
Oh, did I take it down?
Yeah.
I didn't.
Yeah, it's not up there anymore. At least not for
why? For this class?
For this class, I didn't even see it. Yeah, I took it. I had got a screenshot.
Let me check.
Maybe just for the people who do the remote.
I do not know. Maybe. What is this? Maybe. The time. Let's go to.
The first one up. Yeah. Down. Yeah. That's DLA though. Does it make a difference?
Yeah, really different. Semester project proposal is not. See here, this is available.
Yeah, but this is DLA.
Oh, no longer available?
Online. I was on DLA too, I think.
Hey, oh, why? There's a timestamp?
At one time it
Why?
was up and then it was down.
No. Oh, due date.
Yeah. Take the due date
Oh,
out.
because of the due date.
Oh, yeah, that's why.
No, I can. Yeah, due date is still set, but display. This is the reason. Yeah.
Oh, yeah.
Still, you can see it. Although due date is.
But the due date
gone.
was last week. It says the 7th. That was last week.
Yeah, I need to push that because you were not able to see it. So until the due date, it was on, right? But because
No,
it is off because you
ready to display until a certain date.
until this Sunday. So there is a due date, and then you can still see it. You can see it all the time.
So what's the due date of the final?
Final?
When will it be due, the project?
I didn't say. Oh, the final is the
Wait.
first Thursday of May.
We have a final?
Or you mean the
No.
project?
The project, you mean?
Project final and then exam,
Oh, we have an exam too?
right? According to syllabus.
Hey, but
Skip the syllabus. Come on.
It's your call.
Yeah. I
Right.
didn't know we have an exam
Me
here.
too. I thought it was just
Look at the
We
syllabus.
have an exam, like usually in,
Here, syllabus.
yeah, but that's yours. You can do whatever you want there.
No, this is an agreement between you and me. If I don't follow this, then someone may sue me.
No, don't worry, no one's going to sue you for the exam.
Let me see this. Let's take a look. I didn't change this. I posted this first day. I never changed it. Almost everything here in this syllabus. Grading. Assignment 30%, semester project 40%,
Oh, wow.
participation, exam 25%. Quarter.
So what is going to be exam based?
Everything.
Yeah, but I mean like for an app or something, or like Andrino and stuff?
Everything.
All right.
Nice.
We can't skip things yet?
I do not know where that I can put this exam portion to where.
So
Or remove this
assignment?
and everything
but like
proportionally to 100%?
No, I would do participation 10%,
No.
and then assignment 40, and semester.
Are the instructor?
You asked us, well, should we do it? So I'm just
The participation, I cannot do 10% because usually I give full participation, although some students, particularly in this case, we move back and forth. Manhattan here, although you are not here, I do not assume that you are not, right? So which means everybody's. So we'll think about that, okay? Exam, one more project? Hands-on?
I mean, but
Or I would do, okay, next week, as I said, I'm going to give you the lecture about the physics behind the sensor. For example, if it is a temperature sensor, if there is an air pressure sensor, or if it is some sensor systems, so you can pick one sensor and study the physics behind that sensor, and just writing a small paper at the 5-page long instead of 25% of exam. You can take exam or do that.
Yeah, you can do it.
Then, okay.
I mean, if it's 5 pages, yeah. But
Yeah, because
I hate writing papers. But
You want to
if
take a
it's-
25% exam?
Exactly. I don't know. But yeah, maybe the paper, like. But how do you mean the physics, like how it works and everything?
No, you will know next week.
Oh, all right, all right.
By listening my lecture, then,
So we're gonna do research.
yeah.
Is it going to be here? Your
No.
class?
Next week, Manhattan.
Oh, back. Okay.
It doesn't matter to you, right? You can watch.
Oh yeah.
Yeah, online. I have to work.
I would rather be here.
Me too. Okay. So let's do that. But I'm not going to do the both so that you can select
Okay.
one or the other.
Nice.
Uniform. So if you guys do not want to take exam, then long time no see, you guys.
I usually go to Manhattan, that's what. But I have a,
But I don't see you often.
yeah, not here.
I saw you one time only at Manhattan.
Nah.
At least 3 times.
But anyway,
At least 3 times.
I know you're busy for Yankee. Yankee is okay, right? Okay, so if we all agree not taking exam, instead do one paper, one writing, then we'll do that. The way that you need to study is very similar to the lecture that I'm going to give to you next week. I'm going to pick some sensors and the physics behind. Okay, if you describe more detailed explanation, then you will get more credits.
Do we have to do coding on that? About in the paper? No, right? Because it would be too much.
No coding.
Yeah.
So physics,
Yeah, just how it works. Yeah.
right? Principle.
Because if we do just one code, it's going to fill up 2 pages right there. So it's better. Yeah, you're right. It's better physics only.
Right. Okay. What else? So I reset. I need to reset that
and
to.
so the date for the final project is when?
Okay. Okay, that is a good question. The first week, first Thursday of May. That is the last. Everything, anything, everything that you need to do makeup, whatever that should be done by that time. Because I'm going to be away the second week, whole second week. I'm going to be in Spain for conference. If you want to come with me, then you will get extra credit, of course, all the way, because we can talk much.
Hey, if we can do that rather than do the final project, I'm going to take it.
So Thursday.
So semester projects is ideally a group project.
Can we do it on our own?
As I said, alone is possible. It's not impossible, but the quality may not be. Yeah, it's up to you, right? Either alone or a group. So the first Thursday of May will be your presentation.
Here? Or
Here.
Here.
Here. If you cannot make, you can record your presentation alone and make it available for us to take a look. One way that you can make it public is YouTube, right? You can post it YouTube, and if you give me URL, then I can watch, and you can watch also and grade. All the rubrics, grading rubrics are posted, so you need to find out carefully how it is graded. Let me see if it is. Can you see? No, we cannot see it. Let me see if I can do here, grade center. Okay, semester project. Oh, somebody already submitted proposal. The rubrics is this. I set up the rubrics. Right. The proposal itself, relevance to the course. If it is not relevant, then 0%. Very much, then 50%. And the organization of a proposal. So organization 50% and relevancy is 50%.
How many
That is for
how it's.
right how your proposal is organized.
This is just for the proposal.
Just for the proposal. Your final reports has different rubrics. Basically, rubrics are described in this syllabus, so you can take a look. The idea is this: your final reports. I compared two major factors: hardness and accomplishment. Hardness and accomplishment. If some groups try to do very hard problems, then we do not expect much accomplishment, of course, right? But still a reasonable accomplishment, then that is great credits, big credits, right? Some groups try to do simple problems, of course, therefore, fully accomplished, then it's not really full credit because that's the easy problem. Although accomplishment is 100%, but the problem itself is small. I mean, it's not really significant. But still, it's a good points, right? But it's not really big points. And then also organization over your final reports. Finally, presentation. I think 25% each. I'm not sure. You can take a look when you do it. Before we move to, I'm going to change it online class also. If
I think you changed online, but just change Dobbs Ferry and Manhattan.
I'm not sure. I need to make sure that here. I mean, if I don't see any, then it would be okay. Let me see. What is this? This is DL. Did I change DL once? Probably I did the DL, right? DL and MTA. Oh yeah, I didn't change this MTA. So what I need to change is the due date is 16th. This until this Sunday, and then still you can see there's no limit, no close date of reading. Okay, this is done. And then we will do sensor data acquisitions. So today we'll learn a little bit of sensors. Okay. And then next week, physics behind the sensor network. And then following week, we'll come back here, Dobbs Ferry. The final hands-on. The hands-on is not guided by me, but I want you to, by that time, want you to set up your semester projects, so group project or whatever you do. You can make some progress here. the last Thursday in May. And then first Thursday in May, in April, right. Last Thursday in April, I wanted to make some progress here for semester projects. So those who wants to do smartphone apps development, you can do, or sensor development. I have some of the products here if you want. If you have some idea that you want to implement, if I have some sensors available, I can provide for you to implement here. And then first Thursday in May, as I said, that is semester project presentation. Okay, and there will be no exam, although I posted the exam 25%. Instead, I'm going to write up what you need to do. I wanted to do research. It's a real research work. It's not really innovative research, but survey research. I wanted to find out some physics principles behind one sensor. So I wanted to find out one sensor and do some work. If you do the same principle that I cover in classroom or available on this course material, you don't get credits. You need to find out something else. Okay, that's fair enough, right?
What was the proposal for the project? Is that already due?
I set to 16th, this is Sunday. So you have about 3 weeks to do.
Yeah, we have to propose to you something by 16, right?
Yeah, 16, and then you have 3 weeks to complete your project. Any questions? I think that's enough. It's clear, right? To the end of this semester. Okay, what is a sensor? Sensor is a device, right? Device. So, what kind of device? I have a few sensors here. For example, this is a sensor. Anybody understand what this sensor is?
Wireless?
This is all white. What's this and this? This is a motion detection sensor.
Oh,
this is a proximity sensor.
Yeah.
So this tells you the distance.
Yeah.
If there is some objects, then this tells you how far it is. This tells you if you are in some area, some region, then this guy tell you there is some objects coming in my region, whatever the area that.
So basically, they use that sensor to determine the speed and the speed of the police use, right?
You can calculate that also. But some physics behind this, both of this, will be discussed next week so that you will know how this sensor works. Okay? So each sensor has different physics basis. Today I use only these two. Also, I want to encourage you, all of you, to participate our cyber skill competitions. Anybody will come next Tuesday evening? Matthew will come? Great. Jericho, I strongly admon all of you.
Yeah, but how many?
Then you will receive T-shirts, very nicely designed T-shirts. Not tomorrow is different. Yeah, tomorrow is different.
So what?
There's a cyber skill competition. Tomorrow is for new freshmen to college for the discipline of cybersecurity. So they are different generations from yours.
And Tuesday is what?
Cyber skill competition, we meet regularly every Tuesday from next week.
You want us to participate on this
Or we're just gonna
competition?
spend-
Competition, right.
We're gonna watch or we're gonna participate?
Participates.
Oh, next Tuesday.
No, not only one Tuesday, but starting from next Tuesday, we will meet every Tuesday evening,
At what time?
No, till September.
At what time?
6:30 to 8
And where do you meet?
here.
In this.
Yeah,
Yeah, but like I'm done with the school and
you can still. Doesn't matter. If you are in this town, then you can still make some progress.
because I don't know where I'm gonna be with work. You know, like Boston or here or I don't know, or city or I don't know where I'm gonna live. That's the problem.
You can come.
If you start, if you, hey Edmund, if you have a company already offer you a position, then definitely you will leave during summer. But if you do not have that by this time, then at earliest you may leave in the middle of summer, right? That's whole. It takes time, right? No company will hire you, interview today and hire you tomorrow. It takes several weeks, several months. So I'm not discouraging you to leave. You can leave. I am happy if you leave here for your job.
Oh.
You have to listen very carefully. But I'll be a lot more happier if you leave with you some hands-on demonstrable portfolio. How about that?
And what time is it? I'm sorry again. 10 to 2 or when?
What?
6:30 p.m. Or tomorrow is 10 to 2 p.m. 6:30 p.m. All right.
First couple of meetings, I'll give you, because I have some funds received from college. So light, it's not really meal. If I say meal, then from appetizer to desserts, and it's not like that. Matthew, what will be the simple?
Yeah.
Oh, is it more than snacks?
Maybe like some drinks, drinks and chips or something like that.
Oh, this is more than that. You're
more
so
than that.
humble.
Sandwiches and this stuff.
Yeah.
Sandwiches or
But not pizza from this.
no, I'm not. Yeah, this money is not like account money. I can buy and then I can submit the receipt. So we can order here at Dobbs Ferry Main Street. There is a brick, red brick pizza. I love it. Right?
Yeah, that's good.
Brick oven pizza.
Where?
Oh, you don't know?
You mean Dobbs or Irving?
Dobbs.
Oh, Sam's. Not brick oven.
No, not Sam's. Sam's is a restaurant, but brick oven. There's a the first store. If you walk from here to there, on the right hand side, there is a brick oven.
Yeah, I know that place. Yeah.
They serve a very good.
That's good.
Yeah, they
And there's
serve
also
a very
taco-
good pizza.
so there are two
Which
places.
one? Taylor? Taylor?
Or the one on the right is like on the
So
right you have ice
right.
cream.
So what I'm going to do is that we cannot order more than we eat. I do not want to order insufficient
So look,
to
why don't
everyone.
we get here and then order
Exactly.
one
Yeah,
thing?
when we have here and 30 minutes, and then we can place an order, and then we'll do. So please come. Okay, Vishnu. I know you do not have family. You do not have food ready for you to eat every evening. So come. Okay, let's move. So that is a device. Sensor is a device. Here's a mechanism. General mechanism is this. There is an input energy and then output energy. And then there is some transducer in between. In this transducer is a sensor. Okay? For example, since 2007, by the law, all the automobiles should have TPMS systems. What is TPMS?
Something system.
Thank you.
That's the system, I'm assuming.
Something management system? TP? Tire pressure management systems.
Yeah.
So if you purchase cars recent years, then you have on your dashboard, if you have any flat tires, then you will see the sign.
Which
How
year
come
you
it is
said?
possible?
Which year?
2007.
I have 2010, it doesn't say.
Then it violates the law. Which car is it?
Subaru.
Subaru? Oh, Subaru. Okay. I would not say, but
You sure? Maybe you just don't know where it is.
or you never had a flat tire.
I never had a flat tire actually.
So you don't know, right?
Maybe, I don't know. Probably it says, like, if I have a flat tire, it says on the screen, like something, but it never says.
So
the
recent
pressure.
cars, there are tens of sensors installed. That's number one. Number two, are those sensors transmitting their data wirelessly or through wire?
Through what? Oh
Through
no,
rim,
the tire
through rim.
No, the tire pressure sensors wirelessly. Yeah.
Right.
No, those, yeah.
You have a wires
Yeah, but not all of
rotating.
them, yeah.
Wind and rewind.
Because I saw you can buy some of them. Like you can buy.
What about fuel level detection sensor? When you pump gas, then you can see it, right? Some. The typical mechanical based indicator, there's a mechanical things.
Yeah.
Right now there is a sensor installed inside the tank. Inside the tank could be transmitting through wire, but amazingly, the recent cars, all the sensor data are transmitted to the central management systems wirelessly. TPMS, tire pressure management systems. Each tire, there is a rim inside. That sensor is built in that rim, okay? And it transmits. So if you have 4 tires, then 4 different signals comes into that system. If you have some damages, then of course you don't get it. So you have to make sure that if you change the tire, then you have to make sure that you have the signals
I think they
there.
charge you for that too a little when you get into
And also, if your the rim has damages, so that if you rebuild your rim, then you have to make sure that it should have the same kind of
compatible with the
TPMS,
other.
right? The central unit can receive at most 10 tire pressure sensor data. 10. By default, 10.
Why would it be more than 4?
Your spare tire? Do you have a spare tire?
Yeah.
Yeah.
All right.
5.
Oh wait, no. If I have a spare tire, I'm taking the other off though.
No, spare tire has that also.
Okay.
So if you want, you can take your spare tire and find out, oh, this is a sensor, and then put it back. when you put it back, and then already
Yeah,
damaged.
but here most of the cars in America they have like
Right, and then so
small-
some
small
cars,
spare tire. Like,
it has also.
Donut.
Right. Some trucks has four tires in the rear side, right?
yeah.
So 4, 2, then already 6, and then spare, then 7. So anyway, they made the 10. Usually, passenger cars can send 5 signals, right? 4 tires and 1 spare. 5 signals continually send. But 10 receivers installed. So what happens is that if you run and then you have another car next to you, so if you have a very strong receiver, then the receiver receives tire pressure sensor data from your
Yeah, I was thinking that. What if
neighbor.
You have, yeah.
Your neighbor.
What if you are in like traffic and you have kind of the same car?
Therefore, each sensor has unique ID. So that unique ID needs to be known by the central unit in the car.
So if
that
you break
things
a
needs
ring-
to be taken care of when you change your tire rim. So be careful. But you guys are so interested in. So, automobile has a lot of sensors. Not only that, some chemical sensors also. Fuel tank, not only the fuel level, but depending upon, there's some quality of gas. What is that? Octane or?
Yeah.
Yeah, octane level, right? That quickly detect and send it to the dashboard and compute. Therefore, it can estimate how many more miles that you can run with the fuel gas that you currently have.
Yeah.
So if you pump different quality of gas, then recalculates. That sensor is already installed. Most control units, I've never tried, but I read a lot of articles last few days. Available in trunk. You open up trunk and there's a spare tire. Take it out, and some of there, right? I've never seen, but you may, if you have time, then you can take a look. There are some of the control units there. So if you break it, then so careful. So when you reload your spare tire, you have to do very carefully. Otherwise, it'll damage it to the control units. Anyway, there's a sensor. So far, what I explained to you is that the target object that this sensor monitors varies, right? Some liquid, some air, some electric components, some mechanical components, some food, some smells, all different kinds.
Yeah.
Output should be here. So many options, right? Here, the targets, all kinds of materials, all kinds of objects needs to be monitored. But the other end, after the processed by your sensor, the one that you want to receive is very unique. Something about the voltages. Or some current. Some milliamps. Right? Some current or voltages. Not many. By having that number, then your processor, microcontroller, can do some work, right? So all this sensor needs to do that, figuring out some of the phenomena from these target objects and convert that to electric output. That is what sensor can do right now. If you have a gas, there's a gas detector, real, like a flammable gas, or carbon monoxide,
They have that in
or
train stations.
alcohol.
Yeah.
Okay, if you drink alcohol and drive bravely, then you are so brave to enter into jail quickly.
They wanted to put that in the cars, like automatically smell it when you get into the driver.
That's a new regulation.
Yeah,
you know that in the new year, the federal, they want to set up by all the cars. They need to have an alcohol detector. So you're drunk and ignites. This detector quickly identify it.
Yeah.
If you ignite it, then it doesn't. If you sit back, then because of that distance, and somebody sit in front, then ignites, right? So then we have another trick. Somebody ignites and then swap.
Yeah, but the
And
sensor
then
is gonna sense that.
drink drive.
too. Yeah, but then if you sit driving, you're still going to breathe after 1 minute or two.
And
this
then
cars-
stop,
Yeah.
stop it.
Yeah,
That we can do that too.
yeah, it's going to stop.
So smells. If there is a toxic, remember that North Korean guy quickly killed in 2 minutes of where is it? Malaysia, right? Malaysia airport. North Korean's king Kim Jong-un is a step brother. The guy killed is the real brother. He's the son of the first marriage. Kim Jong-un, the current mad guy, crazy guy, he is maybe second or third. He's the son of the second or third wife. The guy killed
Was it
from
first?
the first.
Why? Why he didn't become the leader? Isn't it the first male should be the leader?
No.
Why did Kim take his place?
The third one is more aggressive and grab it, and the first one is more liberal. So at the time, the previous guy died. He was not in that country. He traveled all over the world.
Yeah. I know.
So he was in somewhere. So at the death of that guy, he was with him. So he took all
Wow.
that authorities, and then he tried to kill his stepbrother, his real brother, right? So the way that he was killed is that some chemical gas, right? So two ladies put some chemicals on that, for example, towels, and then cover the nose, maybe a few seconds, 5 seconds, and then he died. That type of things can be sensed by sensor, but if you are killed in 5 seconds, then maybe too late, right? Once you know, then you will die.
I saw also they want to do it like in a road, in a highway. They want to do a laser sensor to sense the alcohol in the car too. Like if this one doesn't go on and the government doesn't apply the car alcohol sensor, there's another possibility to do it like with laser. The laser goes through and then measures the in the car's air and these stuff.
I'm not sure. There is a reason that you have to study physics. Technically, in principle, It's very hard.
Yeah, they send
There are two types. Doesn't matter. There are two types of sensors. I'm not sure. I may. Let me see if I have. Hold on. I'll take your question a little later. Where am I? Okay, here. Hold on just a second. Let me. Oh, why? So hold. Oh. Oh yeah, let me bring this up. Okay, there are two types of sensors, active sensor and passive sensor. Active sensor means the target object itself has some mechanism to emit the signals. So what your sensor can do is that simply receive it. Okay? Simply receive it and identify it. Then there is an active sensor. Passive sensor, on the other hand, there's no emission, so that you have to send out signals, and then that signal reflects from that object, so you have to receive that reflected signals, and then compare two different signals, outgoing signal and incoming signals. And then difference can be converted to some of the indicator. So two types of signals. What Edmund hoped to have is very, very advanced and sophisticated alcohol detector. Okay, doesn't matter X-ray or gamma ray or laser. It doesn't matter. Okay. Smells, you have to think very carefully. Smells, how do you identify smells from somebody else or from your girlfriend? Girlfriend has some makeups, and how do you? Then you can tell very quickly, right? Oh, I have some smells. If you have some cosmetics, then cosmetic has some particles. Particles is coming out from, for example, perfume then is more actively, like LED lights, lights coming out from that device, very similar to that, similar to LED, your cosmetics sending out some particles. So you can capture that particles. Therefore, you can identify. That is a very basic sensing technologies. The way that your nose, if that particle comes into your nose, then you can smell it, right? That is easy. Over the highway, can you smell somebody's cosmetic?
Well,
if it,
yeah, but the sensor is not the same as...
okay, then that is not active sensing. It should be passive. Okay, then laser shoot out, and then receive the reflected signals. Smell particles. That is the reason I'm saying very sophisticated and very advanced technology. It may come in the future, but particle itself does not reflect much. So reflected signals is not strong enough to identify and to be compared with the outgoing signals.
No, you don't need any smell. You just need, for example, the chemical composition of alcohol, for example.
Alcohol is already in the belly.
Yeah, but in your car, like if you're drunk and you step in somebody's car,
right? How do we know?
Smell it.
Smell means is from exhale airs, right?
Yeah, that's
so there's a particle.
Yes, but
right?
when the sensor
but
goes
particle does not reflect signal much. It
observes.
observes.
Yeah, but it's not supposed to reflect. The sensor
if it's
goes
not
through.
reflected, then very hard to compare. incoming and outgoing.
What they said there
Signals.
was a sensor goes through your car and back. While going through in your car, it just detects if it has chemical composition of alcohol, for example, at this percentage. And that happens in a matter of like hundredths of a second. And goes back to the base. When it goes back to the base, it can alarm the police or can take a picture of your car.
Okay, very good fiction. That's good.
I mean, that's
Maybe possible in the future.
No, I
But
saw it,
in physics, there is a very hard physics, very difficult physics. Think about that. I want you to study on that. Okay, Edmund, you already have that.
Well, there is
Okay,
no way,
laser sensor,
It's,
laser-based alcohol sensor mechanism. Okay, that is the title of your.
there is no much
your-
information on that.
There's
Because
information.
You have to find out.
Look, it's called alcohol detection system.
Oh yeah, alcohol detection system
Yeah, but
is possible. Yeah, it is
also
possible.
different.
But what it says is
Yeah,
that
the regulations are-
it's
It says
over the highway.
It tells you, it describes it here.
Hmm? Yeah, study that.
It says so in the vehicle, it measures the level of alcohol in your breath.
Okay,
Maybe it's-
Matthew, that is Edmund topic. What is your question? You raised the
Oh,
hand.
no, you know what my question was, and you just answered it because what I always thought of a sensor is just the detection part.
Okay,
Not
okay.
the
There's
more
a
passive.
yeah,
It's
there is
just
an active and passive
Yep,
sensors.
right.
Two kinds. Okay. Why? Okay, now it's. Oh, because of a number lock. Oh, I know why. Okay. So, some signals in is electric, magnetic energy, or optical energy, thermal energy, and all kinds of energies, right? 2 weeks from today, I'm going to bring my implementation, thermal energy. I implemented that on Raspberry Pi and camera. So camera detects you, and then it identifies different temperature from your body. Okay, so it has been used in the airport when there is a lot of immigrants passing by. That thermal detection camera tells us if there is anybody has some fever. Okay, fever is a good indicator that that guy might have some diseases or something, right? So it plot different density of the color. If it is a really high fever, then it's real red color. So if you have a real red color, for example, here in the neck, then that guy might have some problems in respiratory, right? Respiratory problems, or some other problems. That I'm going to give a demo.
do you know how the sensor? You know that some guys that have cancer, they have it removed, and then they put something here, and then they talk through that. You know, yeah.
When they
They have,
lose
they lose
vocal
cords and
Yeah.
stuff, and then they put something here, and they.
first of all, there is a magnifier. Okay. They know how to pronounce, right? How to pronounce.
Yeah.
So that is converted to magnifier first, and then if it is not really clear, then some of the electric. I think that is a computer science, right? Some clearing noises and other
Noise
than that,
cancellation.
right? Noisy should be cancelled, and all others should be magnified.
And how does that Stephen Hawking computer work, the IBM one?
You're talking about Steve Hawking or
Yeah.
Steve Hawking?
How does that work? He has it
His brain.
in his brain, right?
Right. Not. He has no.
That's from IBM, I think, or Intel.
I think
Microsoft and
General Electric.
Oh yeah.
GE is the best health equipment companies. General Electric. Almost all the expensive, sophisticated medical equipments are manufactured by GE. So GE is the best company in sensor technologies. I mean, a medical sensor, not automobile sensor or not other sensors. Okay. This slide explains to you that I mentioned transducer. This is a sensor. Sensor receives the signals. So this is objects. So objects has some stimulus. Okay. Stimulus can be generated by itself, or stimulus can be the reaction to some of the inputs. So there's this tells you some classifications of sensors, so that we can say acoustic sensor, electric sensor, magnetic sensor, optical, thermal, and mechanical sensors. So we have some of the examples of those, right? Acoustic sensors, you can identify and detect the amplitude, phase, or polarization of waves, spectrum, or wave velocity. Electric, it can tell you the charge of electric. Battery. You have a battery, right? AAA, AA batteries. How do you know that battery is still fully charged or discharged without having any tools?
Wait.
No,
Do you know the weight of batteries
No,
in
no.
full charge or discharged? Yeah, that battery, the weight difference.
I think the phone sends the signal through the battery. For example, if we take a phone.
What I'm saying is, so do not use any others, but battery itself. How do you know?
If the touch it.
Everybody says that.
Yeah, right.
Well, it is no, not necessarily. The
I
best
saw
way is that you can drop battery vertically. Okay, it's not really high, but maybe 1 inch high. Okay, and when you drop it, if it stick to and stand firmly, then that is fully charged. If it is bounced, according to what is math said, it's a little light, so that it bounced, it maybe fall or something. Okay, it is if you drop from this distance, drop it and it stand firmly, then that is fully charged. Some tip. That's electric, so that you can check the charge or current, potential, voltage, electric field, conductivity, and permittivity. Magnetic, similar to that. Optical, also, yeah, various different. Thermals, temperature, flux, and heat. Mechanical. There's so many mechanical sensors are available. Position, accelerations, force, stress, pressure, if you, here's my tip for you to do research for the portion of 25% exam. If you find out the physics principles about these mechanical sensors, very easy. Easy to find and easy to understand. You can understand it very easily. But some others, more high-tech physics, understands.
So what are you saying? If we write about the more, if we kind of do more research on mechanical sensors,
then it's reasonably easy to understand, rather than some others. For example, magnetic or electric. Then you need to have not only physics but electric specific knowledge or background needed for you to understand.
They already have it in Russia.
Hmm?
The laser for alcohol, the police already has it in Russia.
In Russia?
Yeah.
Oh, yeah. Russian physics is far advanced.
I'm starting to imagine the paper.
Good. But principle needs to be described, not principle. Physics principle.
How it works in this one, yeah.
How it is converted. Thing is, how basically is this.
How I'm gonna find how is it?
Yeah, how these stuffs can be converted to this output.
No, I understand, but
So,
how
yeah,
I'm gonna find that out if it's like it's patented? I'm gonna
No,
find
principle is available. Principle. I'm not talking about the implementation.
Yeah.
Implementation may be patented. Okay. Physical phenomenons. If there's an object that you want to monitor, passive infrared sensors, what they do is that they send out the signals and you receive the signals and see the difference between these two, and then convert to that difference to some voltages. Active infrared, because these objects emit some, so that you need to detect it, like smell, light detector, because the light is already emitted from light origin, right? Only what you need to do is to receive it. So I explained that.
So a phenomenon is when
The change of a phenomenon, right? If this change is whatever, if you want to identify this, or if you see identifying the change of this, or identifying itself, everything is a phenomena that you want to monitor.
Mm-hmm. So that's basically the sensor doing its job.
Correct. Yeah.
The conversion.
Yeah. Sensor is so sensor itself has some programs embedded. Mm-hmm. So receiving or identifying some differences and convert that to electric signal. Okay. Okay, what is a wireless sensor network? Wireless sensor network is to use sensor Okay, so it has a sensor and then controller. So maybe sensor is here, right? Sensor that is sensing the target objects and send it to the controller. So in our case, maybe Arduino Uno. Or Raspberry Pi. And according to the outcome of this control processing, do some action. So we have a sensing mechanism and actuating mechanism. So your wireless sensor network can do actuation could be from the reporting, notification, to the real action, some instant response. If your sensor detect explosive gas, if your sensor detects explosive gas in 35th Avenue or 5th Avenue, 35th Street and 5th Avenue near Manhattan campus, then should react quickly, right? Not only the notifying to the human, but react something. So what kind of a reaction needs to be installed? Or autonomous vehicles, when it moves, and then see some obstacles. Any obstacles that vehicle cannot move further, then rather than notification, should do some action, right? So one simple actuation is that turn, or stop, or flip, whatever, or taking off. Okay? That type of things can be done. Did I explain that to you? Our cyber skill competition. What will be done there? I purchased already. Originally, I purchased that for this class, but it's too much work. So I'm going to do that on your cyber skill competition. There's a small cars, small like toy cars. You need to assemble it. It's battery driven, and it has enough space on top. It has already some sensors, proximity sensor. This same sensors is called this. What it does is that if some obstacles identifies, so that it understands the distance, then this guy needs to do some actuation, right? Turn. That's what that car is implementing right now. In addition to this, I want to install Raspberry Pi and Arduino Uno and put the sensors, whichever the scenario that you want to implement. And then I have 4 cars, hopefully 4 teams. We have one other team. That team has drones. They progressed much since last year. So that drones in the air, and we have 4 autonomous cars. So each car can attack others. Not physical attack, but electronic. That is, you may be so very interested in. Join. Yeah, there's a project for you.
This is the one on Tuesday?
Correct. Okay. Because I have small money to use, to buy. So I want to buy, in order to use that money, you have to define the problems quickly. I have to use that money by the end of May. Otherwise, I cannot use it. So have to define the problems, the scenarios, so that the sensors to purchase should be identified early. Okay. If we will purchase, that item should be arrived by the end of May. Therefore, I can get the receipts and everything, delivery evidence, and request for reimbursement. So time sensitive, but if you join, then we do some, right? So please plan for that. If you have this, okay. So what do we need to do? For this class and for computer scientists or cybersecurity professionals, what we can do for this wireless sensor network is not really here sensor portion. It's not really here action portion. What we can do here in this controller, we need to wire properly, we need to calibrate it properly, collecting data reasonably, and we make some action listing so that depending upon the level of finding, we can take one or more actions back to the phenomenon. Or if needed, we can transmit sensor data to upper level of processors. Acoustic sensor. This is an acoustic sensor. Acoustic. It's an ultrasound. Ultrasound. What is the frequency of ultrasound? That we learned last week. At least 20K hertz, right? 20K hertz to some megahertz. So hundreds of megahertz. So this guy send out signals. So in order to identify how many travels that signals should go. So one travel to that object and another travel back. So to understand that object, or to identify the distance, that ultrasonic signals should travel twice, outgoing and coming back.
What's something that uses acoustic sensor?
As I said, proximity, to measure the distance.
No, but I mean, what's something that uses an acoustic sensor? Like, what is it used for? What objects? What daily devices that we might encounter?
When you go
Autonomous cars. Autonomous cars.
Autonomous cars. Okay.
And
even
not only that,
the new
but
cars.
do you marry?
Huh?
Married? Do you have kids?
Yeah.
When your wife is pregnant, have you been to doctor's office and ultrasound? Sonogram. There's ultrasound.
It gets the heartbeat.
Right.
Yeah.
That ultrasound. This signals
Okay.
going into your wife's belly to reach your babies, and then.
So even probably like alarm systems, home alarm systems for the. Well, that's motion. I don't know if that'll be sound though.
Motion is not
That's not
by
sound, yeah.
by acoustic.
Yeah.
Motion
That's
is
what's used here? for example, on our phones.
And voice activation.
No, but for example, like,
This is a motion.
You put it to a top and restart, and it turns out, dims the light of the screen and restart. You know something is there.
This is a motion detector. I have some. You have to learn some principles. So you guys now very interested in physics, right?
Mm-hmm.
What is the physics behind? So if you're without understanding physics behind, then you need to follow someone else. Oh, where should I put? Okay. All right. This is physics. You can get some more information from here. See, this is that sensor, right? Chop signals going into the target objects. Then there is echo signals. The distance that chop signals and echo signal travels are the same, actually. Ultrasound sensor has 3 pins. 2 pins for power, so 1 ground and 1 power, and 3rd pin actually gives you the data. Okay, so you need to receive that data. The other 2 pins, this is a voltage supply, this is a ground, and then this is the data, and data is a pulse signals. So this is a controller, so you need to do some programming to understand, to figure out the distance between this and that. This distance needs to be figured out, but this sensor itself does not tell you the distance. This guy gives you only the time interval. Okay? So this guy tells you, okay, this is the time T1, I have a chop signal out. And time T2, I received the echo signals. And by differentiating T1 and T2, I need to figure out the distance. But because this is acoustic, we know that the speed of acoustic signals, usually 340 meter per second. Right, Vishnu? You know the speed of sound, right?
Yeah.
This is
332 meters per second.
right. This is meter and second systems. For the rest, you Europeans also in this mechanism, right? Only for Americans, inch and signals, sound, second.
Yeah, inch per second.
I'm wondering why the Americans do not use something other than second, minute, hour. Because all other measuring systems are different. Like distance measuring and temperature, what else? Weight, yeah, all different, but not the time. So time is universal. Time is universal, right? But anyway, that's a good thing. So based upon the same time, we can figure that out, right? So
Well, even that's sort of different, though, right? Because the Europeans use the 24 hour, the 24.
yeah. I think this is wrong. I think
No,
meter. Oh yeah, this is right. This is a meter. This is inch. So 340 meter is 14,000 inches. If we change this to microsecond, which means 1 negative sixth, okay, 1 millionth, then 0.34 centimeter or 0.014 inch per microsecond. If we know this, then we can see if this is a distance of 10 centimeter, then what is the time elapsed? Or if we know time elapsed, elapsed time, then we know the distance. Okay? This sensor tells us the elapsed time. By having that elapsed time, then we can calculate it. Okay? So for 1 microcenter, if it receives within microsecond, then say 10 microsecond, then instead of this u, that you can put 10. Okay? 10 microsecond, then we can see, oh, what is the distance? Then 10 times 0.034 divided by 2 centimeter. If we want to get in inch, then same one times 0.014 divided by 2. Then you will see the distance, either in centimeter or in inch. So, a lot of sensors are available. Here is the lab that you need to do. I'm going to give you a lecture and then quick lecture, and then I think we.
The other thing is, Professor, submarines, they use the acoustic sensor.
Exactly. Why?
They can detect the other.
Why?
Yeah,
Why? I said why. You need to know the physics. So
water.
yeah,
And
that is right. But why water? Why is it good? Why is it good in water?
Because
Why?
the way you
Because
can't
we
see
learned
outside
it
of the sewer.
We learned it from the whales. That's how.
The vibration.
Because you can't see too far off, right? And
Not only that.
Like, you can't see miles.
Right.
Light
Exactly.
doesn't
It's
pass through.
the visual is not really as clear in the air, but
Okay.
acoustic sounds travels a lot faster
Sure.
than in the water, in the air. If you shout here, then it takes 340 meters per second. Under the water, it moves so fast, so further. So that's a good tool. You should know that physics.
Well, we gave you options, so.
Yeah. So I wanted to figure that out. Okay. So 20%, 25% of exam portion.
Yeah, but I have something that is not even developed yet. I'm trying to find something.
Or
Physics behind it, like how
at the moment,
and everything.
you can hack in Russian systems.
Yeah, right. I don't want to mess with Putin right now.
Return the favor.
I don't want to mess with Putin now.
I think, let me see. So all these details we'll do in the second half of today's lesson. And meanwhile, let's jump into this. Yeah, we will do LED. What is a LED? Light emitting diode. Light emitting diode. So diode is nothing but like a switch. If you see the diode, then there's two different lengths of a pin. Longer length is positive. Shorter length is negative. Negative is a ground usually. So you have to figure that out. LED, there's two types of LED. Emitting, receiving. This is emitting. This is emitter. This is a receiver.
Are they always together? Can you use one
Yeah,
or the other?
one LED can do both, receiving and send, emitting and receiving. What about the LED lights over the streets? Many of the streets already replaced with the LED lights, right? Mm-hmm. You notice that, right? When you walk down the streets at night, some lights is so bright, then there is LED. You look up, then you can see the all LED lights. If some lights like lovely, warm, brown-like lights, then that is old-fashioned lights. Difference between those two are not just the brightness, but because there is a LED. LED is what? It's a signal. It's a frequencies. So you can, if you mix that signal with the data, then you can transmit. Data transmission is possible. Give me an example of such data transmission.
Like the time when they should come on.
I'm not sure it is on. It is functioning like that. But yes, it's possible. Every home has that.
Remote.
Application, yeah, remote controller. Remote controller has LED lights. One light. The old LEDs has lights in it, right? You can see the lights. But the recent ones lights is removed. Only the signals. Because the lights made some damages to somebody's eyes. So they try to remove. So brightness is very low, but still the same signals coming out from there. Same frequency. About 400 megahertz. 400 megahertz signals coming out from that LED-based remote controller. Almost all almost all remote controllers are based on LED. That's what we want to do. Okay, lab tips. Get familiar with the sensors and wire the sensors to the circuits and the board. We have Arduino Uno board today, and then there is Arduino IDE on the host that should be available. And then get Arduino ready, connect Arduino with the circuit board to the host, and configure the type of Arduino and the port to which the Arduino is connected. And if your code is successfully compiled, then it should be uploaded to the Arduino board, and then run that Arduino Uno. Okay, that is basic idea. The Arduino IDE looks like this. If you download and install Arduino IDE, it looks like that. That is the icon. Alright, so please download it from, for example, you can do Arduino IDE. Arduino IDE download, then each platform has different IDE software available. For Apple, you need to download the right version. This is 2015. So Arduino CC, yeah, that is the right one. So go to Arduino CC, Arduino CC /EN, EN for English, and main software. Then there is Arduino web editor. Download Arduino IDE. So this is the version 1.8.2. This may be the current version. So you can install either using installer. If you download this, then it link to the place to download, or you can download a zip file so that install that file locally on your system, or Mac OS, Linux versions. So you have to do that. So once you download it, and then this icon is appearing on your desktop. So double click it. Then you will have this. This is IDE. So I want you to have this is Arduino 1.8.0. So 0.22 version different. I mean behind. Mine is a little behind, but you can have it. Then you have something. So Orion firmware. Okay. So I'm going to. I didn't expect that we have this many students today. Usually we have 3 or 4 students. So, I mean,
So we're gonna go to the.
can do. Anybody has Arduino Uno on your own? No, not yet. So I think 2 each you can practice. So 2 of you.
I know, right? I don't want to do it.
Huh?
Yeah.
We gotta, we should download it.
You don't want to do. What are you going to do? There's 1, 3 of you, and I'm going to use 1.
You're gonna download it then?
No, IDE first. IDE first downloaded, and then I'm going to give it to you.
What do we need to download, Professor?
IDE.
Arduino Uno software.
Do not connect it yet.
You come download it.
So there is a power outlet, right? Power inlet, so that you can plug this and connect it to your PC. So I'm going to close this. Let's get familiar with this IDE. There are menus on top. I think 1.8.0 or 2, hopefully the same.
Yeah, but don't continue over there. Let us download it first because then we're going to be far behind. Seriously.
I know you are so smart to do multi-processing. So while you are doing, you can also hearing my explanation, and also you're watching something else,
No, I'm
and
not.
you are thinking something else.
No, I'm not seriously. But he's downloading it, so now I'm gonna listen to you.
Sure. So you can see it. I want you to take a look at menus. So there's a new open, recent, sketchbook, examples. There are a lot of examples. So you can download some. You can take a look some of the examples here. See a lot of examples. Last semester we did RF24, right? There is AES library for cryptographies, and wire, SPI, software serial, EEPROM. If you want to save something on your microcontroller here, this one has 256K memory space, quite big.
Yep.
And Wi-Fi. Right now, this is not Wi-Fi Arduino Uno. I ordered Wi-Fi Arduino Uno Wi-Fi. Personally, I purchased during winter break, so that only this semester I placed the order of Arduino Uno Wi-Fi. But all of a sudden, discontinued. I do not know. There may be some issue. I'm not sure. Technical issue or something else. But I have. It is powerful. It is connected to your Wi-Fi router and do some great thing. These small things can do.
To Wi-Fi router or to your computer?
Here itself. This itself receives Wi-Fi signals.
Yeah. From your computer, like you're saying to connect it through Wi-Fi with the computer and code it?
No, without computer.
Oh.
Okay. So, what language is this programming language that
C.
Arduino uses?
C. But you can import Python.
Other libraries,
Basically Python or C. Same thing, Raspberry Pi. It has C or Python. What is that?
That's right. See, he's used to Yeah, got one.
He got a good actuator. What's that one?
Yeah, what? I'm sorry.
It's good.
There's
This is
something-
good. And that bugs.
Where's the man?
I was sitting here from 250. Multiple times he hit me. It's scared.
And once it came to creation, right away.
Bibles or the, you know what?
So I owe one bug to Croatia.
You owe 5 credits to him.
Oh, sure.
5%.
Great. Okay, so I wanted to take a look some of this. So examples,
I don't think that's it.
GSM.
You see me? You sure? Yeah.
We don't do much.
I know, but yours is a sketch. This is not the...
Right. And then edit. Here we do some and sketch, verify, compile, and upload. Those two things that we need to do. And tools.
For what? For the one?
Board needs to be identified.
That's what you want?
Okay, this is one thing very, very important. All right. So I want you to here. You have to follow at the right pace so that we can finish up before 9 o'clock. So hands-on takes longer and longer. Okay. Are you all almost done about download ID?
We downloaded.
Yeah, connect it.
Yes, sir.
Connect it to your laptop. And then here in tool menu, go to tool menu and down, then there is a board selection. Board. make sure that you have Arduino Uno. Okay, Arduino Uno. Arduino or Genuino? Anybody here knows Roman, Italian?
Italian?
You're close to Italian, right?
Yeah.
What Arduino means? Or
I can search.
Genuino. Genuino.
Is this, Professor,
Huh?
is this a sensor itself? What is
No, there's a microcontroller.
microcontroller?
Yeah, I'll give you a sensor in a minute. If you look at this, I'm going to explain this for you first.
Everything is there, right? Like even the
Yeah, you can. There are 13 to 15 pins. This is digital pins for input or output. There are 5 pins, 6 pins for analog input. Analog input. Okay. So A0 to A5. So that is analog in. There's a digital pins 0 to 13 or 14, 15, yeah, a little more pins there. There is a digital. These digital pins can be used for input and output. And those digital pins are PWM. PWM means pulse with modulations. So pulse, that's a digital. It means digital. And some lights on. Find out there's a TX on something. And then there is a some rectangular, like a memory-like processor. This one has, this is an EPROM processor and processor in it, and memory also.
In Italian means strong fan. Strong fan.
Arduino means?
Arduino means strong fan.
Strong fan.
Strong fan, yeah. Strong? Yeah. Or genuino means G. Genie.
Genuine.
Genuine. Yeah.
Genuine. How come they come together? Strong, I mean, Arduino and Genuino.
That means genuine strong friend.
No, I mean, genuino probably it's another.
There's a one or the other.
Yeah.
It's Arduino
another,
or
yeah,
Genuino.
It's different device.
with different purpose.
No, probably
Yeah, they're the same. That's what they do. Okay, so when you have a sensor, then we need to sensor if it needs power. Most of the power needs power. Most of the sensor needs power. So we have here. Look at the power, the left side, not the digital side, not the longer, the more pins side, but the smaller pins. There's a reset 3.3 volt, 5 volts, and 2 grounds. So 2 grounds and voltages needs to be a power supply. And one of the pin here in the digital pins, if your sensor has data outlets, then you need to jump that data outlets to one of the pin here, digital pins, and in your program, you need to identify, you need to specify, hey, I'm going to listen, I'm going to read this particular pin that I connect from my Arduino Uno to the sensor. Okay, that is the idea. All right, so I wanted to make sure that you have that board and port. You need to see COM port 1 usually is not for your Arduino Uno, but you have to find out if there is another COM port. It says Arduino or Genuino Uno with that COM port label, then click on it. So that when you come back here tools, that you have to see, oh, there is a board, there is a port. Make sure those two elements filled in. Okay? All right. Then sensor that we are going to practice today is
Yeah, I didn't have that either. You didn't see that column, right?
is this. Arduino Uno HCSR04 ultrasonic sensor. So this is the sensor I'm going to give to you.
And the cables, you need help?
Oh yeah, this is heavy.
I'm going to use one of those and one here. And you need to unpack it. If you see this, there are 4 pins. In your sensor, there are 4 pins, right? The one pin that is the ground, and one next that is the echo, and the other one is trigger, and then at the other end there is a VCC. So VCC and ground, 2 pins for the power supplies. VCC, then you need to link with how many volts? I think 5 volts. 5 volts needs to come into this VCC, and ground for connected to ground. Okay, so I'm going to give to you.
Yo, which pins here in the Arduino are for ground and for VCC? How do we know? Which pins are here for ground and
one is two on ground, GND, yes, and then the other one,
BCC,
Echo and V-Star. What is that? Echo? Yeah. Yeah, bro. VCC, which one should we choose? 5 volt or 3
5
volt?
volts.
5 volt, okay. Yes, sir.
5 volts.
Yeah, but no, don't do it because he's gonna give us the cables.
Let me choose first. You have to choose this very carefully.
Otherwise, we're gonna burn.
No, not because of that. There's a male and female. Here's this. Look at this. Your sensor already has pins. These are male, right? So at this end, you need to have a female. Don't be laughing. And then your Arduino Uno, they're all female. So you need a male. So your jumper cable should be one side the female and another side the male. That I picked here like this. Male and female. 4 of those. I have a bunch of it here, but they are not all male and female. Some male, some female, some male. How many combinations?
3 combinations.
3 combinations. You're very good. So pick 4 cables.
All right, sir.
And then be careful that the cables should be plugged in the right connection. Okay? If there is a ground, it should be ground to ground and voltage to voltage. And then this guy has 4 pins, so 2 pins for the data, right? Remember that this ultrasound distance sensor needs to take 2 data. So one data from chirp signal, the other data from echo signals. And then compare those two signal difference and convert that to, and then you have to some compute to measure the distance. Okay?
All right. Downstairs. Should go down 154.
In here,
Wait.
and then these, they're gonna go into.
You need to have
We need-
different. This is a male.
We need to.
This ground to ground
Yeah.
and voltage to voltages.
No. Some of them. They don't do it. Yeah.
Two. Echo goes to two. Wait, stop. 12 or 2?
No, it's 3 and 2. Digital 2.
12. 12.
These are the ones who
12. 13, 12.
12 and 13.
Yeah. So wait a second. Echo, where is it going, Echo? And it's going to 2, right?
Yeah, it's going to be 12.
12 and 13. Okay, now what do we have to do?
And then trigger pin and echo pins.
Yeah.
Echo pins.
Echo on 12.
Echo. Echo 12 and trigger 13.
And, yeah. Yeah. Now we connected, right?
Okay. After that,
What about the other two?
you have to do new. If you have anything here already, then ignore and click new. So that you need to have a new editor.
It's not 31.
So I'm going to close something that I have already, and I need to make sure that I have a board and port. That is okay.
Yeah, 12 and 13, yeah. And then what about the other
The
two?
ground goes to here. On the other side, ground, you see 5 volt and GND. You see?
GND, yeah.
GND and 5 volt next to each other.
GND, yeah, and then 5 volt.
Look, GND from here.
Oh, that's why I can see the closest one that's
Yeah, but
5.
from here, GND goes to GND.
I have still a lot of work to
Yeah.
do.
Look,
Okay.
I see.
So,
which one is GND?
can
The brown is
so
GND.
can my master's
so
project
this is
substitute
GND.
the class
Yeah,
project?
The one closer to anyone, okay?
And then the
Oh, if you do this,
goes here,
great.
To VCC, because
I mean, great extension,
you have 5 volt.
Yeah.
Yes.
not the
No, it's
minimum
not turning on, man.
But I don't have much to be you can
for
do.
them.
Yeah,
Yeah, it's just-
Of course.
Expressing that.
Yeah, of course. Then we can do.
Yeah.
Because it's all Swift limit.
Okay.
Have a great Easter, guys.
Hey,
All right.
see you. Happy Easter. Let me know about that, huh? Please. Tickets. Officer, mine is not turning on though.
Which one?
The Arduino now. Oh,
So now,
yeah. Yeah, well, but before
Is it connected to your laptop? Okay, let's move. Otherwise, we cannot finish. I think Yeah, let me do. Okay, you follow.
You follow?
If you see this editor, then this is very important. You have a void setup. There's a setup block. Here there's a open curly brace and close curly brace. We have nothing in it, right? So this is an empty block for setup. We have another empty block for loop. Here, loop, right? Let's practice one here. First thing that we need to practice here is that I want to do serial dot begin, and then 9600 baud rate. Back here, loop. I want to do serial dot print ln. I want to do hello, I am here near you.
Serial dot what?
Serial dot begin and serial dot print ln.
Print ln.
And then all should be ending semicolon. Okay? So 2 lines each. What it does is that
Is that a semicolon or a colon?
semicolon.
Semicolon?
At the setup, you need to set up the communication. Communication between communication from your here Arduino Uno. Okay, communication.
This is not working, I think. It's not our fault. This was the old one that you gave it to me. It wasn't like this.
Can you indicate this so that I need to? How do you know it is not working?
Because it's not turning on that. When I took theirs, it's working.
Okay,
So I'm going to try this one and see.
sure.
Because I wanted to
Yeah.
know if the Arduino board
Yeah.
is wrong or that one.
So I'm going to. Okay. All right. After that, there is a tools, and there is a serial monitor. If you see the serial monitor, it's a serial. Serial means we set up serial, right? Serial begin, so baud rate is 9600, and serial printout. I want to print out this text in the serial line. So let's see. I want to open serial monitor. Bring here serial monitor, and then I need to change this baud rate to 9600, and I have something, but it is not really.
How did you run that? Send?
How do I run? Here, serial monitor.
Uh-huh.
Open, and then check this baud rate. It should be 9600, the same as this.
Yeah. But I get a bunch of
Right, numbers. So what we need to do is that we need to, it goes so fast, right? So we need to make some delay. Delay, say 500. Oops. Oh, we didn't do anything yet, right? Well, we need to save this. After this, we need to save. How do you save? Here, save. Then you need to make sure that where it is now documents and Arduino, right? make sure that it is there, and then you need to do file name. File name should be my distance, so ultrasound distance sensor, right? Save this, and then we need to compile this. There's icons. Top we have menus, below we have icons. The first icon, if you move over to that, you move your mouse over to the first icon, then there is an explanation here, annotation. It says verify. Verify means compile. So click this, compile, and watch here to see if any errors. If you have any errors, then you have red colored text. If it is not, then white. Compiling sketch, that is currently going on, right? Okay, so compile is done. And after that, second icon is for upload. So click this. So compiling, sketching, and uploading. I think uploading is done. And after that, so what it does is here is that this program is now loaded here. Now this guy, Arduino Uno, is running that program. So we need to see. We need to monitor that program. See here, it says, hello, I am here near you. Hello, I am here near you. How often? Every 500 microseconds. So what is the idea of Arduino? Arduino Uno is this. We first set up something that we want. And everything within this loop is running endlessly, 24/7. And now next thing that we need to do is we need to identify these signals, right? So I'm going to close this and see if we have something. We need to. This program does not understand which pin needs to be red, right? Because this sensor sends some signals like trigger signal and echo signals. So we need to define that once first. Here, define trigger pin. I said 13, and pound sign is not a comment in C. Pound sign is one of the program. It's not like a Python. Python's a pound sign is a comment, but here it's a definite. When you do define, then you need to have a pound sign, and then echo. Echo pin is a 12. And in this setup, you have to say pin mode, and then this trigger pin is output, means signal needs to be sent out from your trigger pin, like a chop.
Yeah.
Your sensor needs to chop and then receive an echo. So another pin mode, echo, pin should be input. This is it. In this way, your experiment is set. And then whatever you want to do, the continual execution or workout needs to be specified in this loop block. In this loop block, there is a digital write. Digital write means I want to write something on that pin, but that pin is an output pin. When I write something on that output pin, it means that points I want to send out the signals. Sending out signal statement here is nothing but digital write. So I want a digital write trigger pin, and then low is some value, so on and off, things like that. Let's do high. Okay, high. And then I'll do digital write trigger pin low. And then we need to define here upfront some variable. So long number, we can say duration. All right, and then that duration is nothing but pulse in. That's anything that you see here, the orange color, that is the reserved word. That is a command. That is not something that we choose. Black, that is something that we choose. So that we need to define, for example, duration, trigger pin, echo pin, number 13, 12. They are all something that we pick. Orange sign, that is already defined, but we use it. So we make difference, pulse difference between trigger pin and echo pin. So echo pin and high. I think that is it. Digital write. High, digital write high and low. Okay, and see what happens. And then we do serial.println and then duration. And try to upload to see if there's any errors or problems. So done. Let's do monitor. See, we have when I move this, see some number, right? There's a distant time difference. When I move slowly out, It's not really. Let's see. Very high, right? If I do this long distance, it takes a longer time. But if I here to this monitor, a little shorter. If I do this to this wall,
But you can't hear what echoes, right?
little longer. Huh?
You can't hear what echoes, right?
No, this is ultrasonic, so we cannot hear. This is not hearable frequency. So those are the microsecond. So we need to compute that microsecond in inch or centimeters. How can we make it? We can make it using this duration. So another long variable, we can say distance. So distance can be computed is a duration times 0.34 divided by 2, that's centimeters. So we can say serial dot println, and then you can say distance ln. You don't need to do it. So print only and space, and then you can do distance. Centimeter. Okay. So
Is that the code?
yeah, code that I made. We'll see. Okay, that is loaded and monitor. Okay, right now, if I do this to this wall, what is the distance? It's 87 centimeter, about that, right? So it's less than one meter. And then if I do here to monitor, this has some calibration, right? If it is too short, it doesn't understand. So something else. I think this is light is not really. So 100, a little bit over 100.
Okay, 120.
Yeah, 120. About that, right? Depending upon the accuracy of this sensor, is that if I put this to the ceiling,
34.
3400 means 3 meter, right? This is 3 meter, right? If I do this to back wall,
It might need something else.
it doesn't detect yet.
Too far.
Too far, yeah. So somehow calibration is needed. All right. This is one simple sensor programming. You guys done? Okay.
Are we done?
Yeah.
Oh yeah? I'm still trying to make it work.
Yeah. Make it. I'm going to close.